Hello everyone, welcome to our online open course. We will learn the final process of program design for flat and straight wall products. This process is the precision machining of internal grooves and groove corners. The process uses the method of flat milling, similar to the flat contour machining method. It only requires creating a 2D wireframe without the need for 3D modeling to carry out program design. The programming steps are as follows. First, enter the UG machining interface. Open the part machining option and copy-paste the existing rough machining process of the outer contour. Second, modify the toolpath parameters accordingly. Third, generate new tool passes and simulate them. Fourth, create a machining process list. Fifth, check for allowances and residual thickness. Sixth, generate post-processing files. For detailed operational specifics, please refer to the skill operations. This operation involves the finishing of internal slots and corners. This process can also adopt the rough machining operation used for groove corner roughing. We will start by copying the previous operation. Click this process. Right-click on the operation and select Paste, renaming the file to Internal Slot and Corner Finishing Operation. Double-click on the operation and modify the reference tool in the spatial range of the cutting parameters to none. Then click OK. Back in the cutting parameters, change the allowance to 0 and click OK. Other parameters can remain as default. Ensure the tool used is a 10 mm one. Then adjust the feed rate and speed. Set the spindle speed to 2500 RPM and the feed rate to 500 mm per minute. Then recalculate. Click OK to reflect the high speed, low feed characteristics of finishing operations. Then click Generate for the system to computer and create the tool path. Right-click, select Tool Path, then find OK, and click Play. For the simulation. During the milling of closed internal contours, ensure that the entry and exit points for normal cuttings are ideally positioned at the intersection points of geometric elements. For materials with significant plastic deformation, high thermal strength, and severe cold hardening, it is advisable to use sequential machining whenever possible. During milling, each feed milling depth should be only 0.1 to 1 mm, and the process should be done rapidly and reciprocally. layered milling is preferred. Planar profile milling operations involve two-axis machining. In UG System NC automatic programming, NC operations include creating geometry, creating programs, creating tools, and establishing machining methods. We increase the speed. Then click OK after the simulation is finished. Next, right-click with the mouse, locate Post-Processing, and open the corresponding post-processing file. Set the units to either metric or imperial, then click OK. Then click OK to override the original file. Our machining program will be generated. Afterward, we can modify and optimize the program based on the specific conditions of the machining equipment. The skill operation is now complete. Students should complete the extended training based on the programming of the learned products. In this lesson, we completed the fifth progress of program design for flat and straightforward products on the UG software platform. The difficulty of this process lies in the selection of cutting parameters. The contour milling method was used in the programming process. Students can practice on their own based on the operation demonstration, carefully understanding the use and characteristics of the above machining methods. Apply the knowledge to program designs of similar products. Thank you for listening.